This tutorial illustrates constraints to the model builder, in particular constraints to the geometry about an atom geom. So let's build something here. Let's just take some carbons, connect them together, and build this, and we obviously get a tetrahedral molecule. Now let's take and select this carbon atom, and when we apply constraints, we can constrain various things here depending upon what we select. When we select a single atom, we can only constrain the geometry. If we selected two atoms, we could constrain that bond length if they were bonded, or a bond angle or bond torsion. To constrain the geometry about an atom, the atom geometry, is either the same as it currently is, the computed value. It's linear, trigonal, tetrahedral, etc. And what we're going to do is constrain this geometry to be square planar. So we've now constrained this atom to be square planar. That constraint takes place when we model build. So if we now model build, what we get is a square planar carbon. And so that's a constraint to this atom geometry. If we select this atom, you'll see on the status line that it's built to square planar. Now let's constrain something else. Supposing we take this bond length here and we go up and we want to constrain that bond length. It's currently 1.54, and supposing we want to make this very long just to show the difference and constrain that to 2. Again, this constraint will only take place when we build, and so now we have a square planar complex here where one of those bonds, 1.54, 1.54, 2. This one here is 2 angstroms long, and this one is 1.54. I guess I should have made it longer so it's more obvious that that's a longer bond length, but that is 2 angstroms, and it's longer than the others. So anyway, when you're building molecules, you can, if you like, apply various constraints so that you get the kind of structure that you want built. In particular, bond lengths, angles, torsions, atom geometries, and so on can be constrained. These are quite different from restraints, which is another topic in hyperchem.